and welcome everyone. Today we're going to actually code in C++, and moreover, I'll explain you what I am doing exactly, how am I thinking, and I won't leave you without any gaps in your head. So you will understand the code, you will know what each line is doing, and all the details of each function. In our last class, we created our hand, and we created our character base. So what I want to do right now, and go to our C++ classes, VR template, public, and hence. What we are going to do, we're going to create a blueprint based on C++ class. So let's right click, create blueprint class, and let's put it in content folder. I'll code bp left hand. Why left hand? Because we'll just copy it in the future and code right hand. So we'll code one hand, copy another hand. So for now, I'll code left hand, and let's click create VR hand class. And once we open it, we're getting empty blueprint because basically our C++ class is empty. And we have some default scene root created. So C++, once you create any actor, you have this default scene root. It's created automatically. So when you add new components like static mesh, it will be attached to this default scene root, and also you can replace it like that. So before we continue with our code, I want you to warn that we need to add some dependencies. What do I mean by this? When we created our project, we created it for Blueprint, right? We didn't choose it for C++ specifically. So we'll have to include some dependencies for our C++ to know that we're working with VR. And those dependencies will allow us to access VR specific classes like motion controller component, widget interaction, those only VR targeted classes. So how to do it? We need to go to our source folder and we will see here a file called yourprojectname.build.cs. Let's open it. And what we'll have to do is we'll have to add in our public dependency modules head mounted display, and we'll have to add UMG. This basically connects Unreal Engine with some other modules for us to work with specifically VR, so we could work with classes. Okay, and make sure it's head mounted display and save your file. Make sure you save it because you won't be able to compile. Okay, now we are completely ready to code. The first thing I want to go is to see how our VR pawn works. So let's open VR pawn and look. The most important component here is motion controller. That's basically your actual motion controller that you use with your headset. And if you hover over it, you'll see that in parentheses, it says motion controller component. And usually it tells you about how C++ class is called. So we have a C++ Unreal Engine and we have Blueprint ones. Blueprint is based on C++. So here in 90% of cases, this is the exact name of C++ class. So let's go back to our Visual Studio. How can we find the C++ class? Because we don't know how it's even called correctly, right? So what I would suggest you doing, and it's another hotkey, once you want to create a class and you don't know its name, you don't remember, you can press Ctrl-T, you'll open a search bar in which you'll have access to all C++ classes in Unreal Engine. And let's type motion controller component. And here you'll see its CPP file, so let's open it. And I will press Ctrl-KO to open its .h file. This is the hotkey from our previous lecture. So if you scroll up, you'll see class motion controller component. And as you can see, it's defined same as our AVR hand. And this is the exact name we should use. So we have a variable name and its type. This is our type. So now we're going to copy this motion controller component. We're going to our VR hand. And now we have three places we want to put it in: public, protected, and private. So let's start with public. Okay, public tells us I can access this variable wherever I want, even in other classes. Do I need it for now? No. In case we'll need it in future, we can drag our variable to public, but for now, this is not somewhere I want to create my motion controller component. Let's see for the protected section. Protected section allows us to access variables in inherited classes. So if we inherit from AVR hand, like we did our hand from actor, and we are able to access this variable in AVR hand. And this is something I really like. Maybe I'll want to derive from hand, so I will want to access its motion controller. And let's look at private. Private makes it only accessible in AVR hand and only there. So maybe I'll need it in future in derived classes. Maybe I will want to derive from AVR hand, so I'll put it in here. So let's say motion controller component. And of course, we're going to use the pointer form. Why pointer form? Because pointers make your code much more optimized. And for now, we're going to code motion controller. Okay, so why we have those red squigglies? The reason is that despite we have it's defined here, but our hand doesn't know anything about motion controller. How we can create our motion controller if we don't know what it is, right? So for this purpose, we're going to go to motion controller and we need to include it in our hand. And the way you're going to include it is always go to CPP file. So I'll press Ctrl-KO again. It's CPP file of motion controller component. And always in the first line right here, you will see the right include command you'll need to copy. So we'll copy this and we'll tell our VR hand, okay, look, now I told you what is motion controller component. And as you will see, we no longer have those red squigglies. Now, once we did this, let's see what we have done. We have created motion controller component, motion controller, and I told you in the previous lecture that by default, this is null pointer. It doesn't point anywhere. It's like a teacher showing you in the empty space on the board. There is nothing inside by default. So this is something that is happening. So obviously, we need to fill our motion controller with some data. When do you press this add button and you want to add some of the components? You see, we clicked it and we added skeletal mesh, for instance. How to do the same in our code? We are going to say motion controller. So now we're going to create an object in this memory cell and make our motion controller point to that object. So how do we do it? There is a function in Unreal Engine called create default subobject. Here, we have to specify what type of object we are creating. And our type of object is motion controller component. And let's give it a name, motion controller. So now we created an object. So this equal sign, you can see it returns motion controller component. So now we create an object on this address. Our next step is to tell how do we want to position component. Maybe you want to take this, our motion controller component, and set it instead of our root mesh, or we want to do something else. So I would prefer having our motion controller created and set our default scene root by motion controller. And our default scene root, this thingy right here, is called root component. Because if you go to a actor, right, we can look for root component. And here you'll see a variable. It's TObjectPtr, scene component, root component. You see our root component is a scene component, and it uses some kind of TObjectPtr. We'll use it too, but I will explain you later what it is. But for now, let's come back in here. So we want to set this root component. There is a function set root component, and let's specify what we want to replace it by. And we want to replace our scene component by our motion controller. Great, so now let's save everything, pressing Ctrl-Shift-S, and let's go to our Unreal Engine. First of all, I'm going to delete everything from here, and I'm going to compile my code and see what happens. And I got an error here. I had to write display instead of DCI play, so I will go back to my Build.cs and I'll fix this issue right here. So head-mounted display, and I'll compile again. So as you can see, it's successfully compiled. Let's go to our hand and see what happened. Now it's hit compile, and what we can see right now, our root component has been replaced by motion controller, but we have some problems right here. Our details panel is empty. We cannot edit our motion controller. Maybe let's try to grab it and use it as a variable. And what we can see, the result from here is scene component object reference. But wait, didn't we say that we have a motion controller component? Yes. For C++ side, we have a motion controller component. So C++ knows it is a motion controller component, but blueprints do not know. In C++, we have to use a specific property to make blueprint understand that this variable, we want to have control specifically over this class. So to link blueprint to C++, we have to use a specific macro called UPROPERTY. And this UPROPERTY establishes connection between blueprint and C++. And afterwards, UPROPERTY has a couple of things we can plug into those parentheses. And the first thing we're going to learn about is edit anywhere. We are telling that we want to establish connection between C++ and blueprints, but for this specific variable, we want it to be editable anywhere. So we can edit this variable inside our level and inside the blueprint. And there is another type that you will see most common. This one is edit default only. This will restrict editing properties of motion controller only in details panel. But I will leave it as edit anywhere. We want to edit it anywhere, right? So let's compile right now and see what happens. Make sure you save your CPP files. And now I have it compiled successfully. Let's go to our hand and look what happened. Our name changed to motion controller, and let's delete this one and drag this one in here. Now we have motion controller component. We can click on our motion controller and we see everything about it as you used to see in blueprint version. So what it tells us? It tells us that we have a control over how much we want to expose it to blueprint. Let's see another problem we have. let's try to access some property of our motion controller. Let's say we want to get its motion source, and we want to print it. Let's compile. Oops, we have an error again. What it says is not blueprint visible. So despite us of having this variable in here, we can use it, it's not readable. So we did not give permission for blueprint to even read properties of that variable and even write it. So what are we going to do? There is another thing we can specify, and this is the amount of control we give to user in the blueprint. And the property here to fix this issue is called blueprint read only. So now this parameter tells blueprints that we can read the properties of this motion controller. You see how much of a control C++ has over. You can tell the user, your developer team, how much of an access you want to give to this variable. And there is another property you might see. It's blueprint read write. We don't necessarily need to write our motion controller. Like, we don't want to replace it by another motion controller, so I use read only in here. But we'll see read write in future tutorials. Let's compile it right now. Make sure you save it. And your code should be saved as well. So it compiled successfully. Let's go back to our hand. We'll get its motion source. We don't need to set it. Get motion source. And we're going to try to print it. And as you can see now, we don't have any issues. So that's the power of C++. You have an exact control of everything you do. Okay, great. I'll delete this code since we don't need it. And let's hit compile and save. Okay, other thing you might find really creative. You remember how we created variables, right? And we gave them category. So here we say, for instance, setup. And now our variable is placed under category. The same thing we can do in C++. And in order to do this, we just write here, category equals, and you give it a name. For instance, components. Let's compile and see how it changes. So we will go to our blueprint, click on this gear icon, and make sure you show inherited variables. Since our BP left hand is inherited from VR hand, we can see its variables, and as you'll see, they are put under components. So we gave them category components, and they're put under components. So that's how we create components inside your class. So next component we're going to create will be a skeletal mesh component, right? We need our skeletal mesh for our hand. We need to see our hand. Therefore, let's go ahead and look at its name. It's going to be skeletal mesh component. And usually it's the C++ name in Unreal Engine. So I'll delete it from here. We'll create it from C++. I will go in my Unreal Engine. I will press Ctrl T, and I will look for skeletal mesh component. As usual, we'll try to look for a CPP file in here. And there we go, skeletal mesh component. And here's, as I've said, the first line will be the line you need to include. But here's a cool part. Do we need to include it? Let's see our parent, a actor. Sometimes the parent class already includes the skeletal mesh component. And as you can see right here, actor.cpp, our parent class, already includes skeletal mesh component. So we don't need to include it again. But don't worry, if you include it, you can still include it here, right? But we have pragma once. And basically what it does, it prevents you from repeating includes, so you didn't include whatever is already included. But it doesn't matter. If you write it here or don't, it's totally okay. For our purpose, I will not write it to make sure it works. Our skeletal mesh component, let's see how it's called. Class use skeletal mesh component. That's the variable type we're going to use. Let's go in here, and the same way, use skeletal mesh component and mesh. And you can see it's not going to be underlined. It's already included in our parent class, so we don't need to include it here. And we're going to use the same property. Now let's construct it. How do we do it? Again, we have created a pointer, hand mesh, and currently it points to nothing. Therefore, let's make it point to somewhere in our memory. We need to create this object in our memory for our pointer to point. So I'm going to take our hand mesh. The same way, I'm going to create default subobject, use skeletal mesh component, and I'm going to call it hand mesh. Like this. So it returns us use skeletal mesh component. You can see the return type right here before function definition. And now, once we wrote this line, here we'll have skeletal mesh component, and we automatically make our pointer point to already existing memory cell with our skeletal mesh component. And remember, we want to attach this hand mesh to motion controller. And how do we do it in Unreal Engine? The way we do it is we say like that, hand mesh, the reference operator, we use one of the functions, and we use setup attachment. And now we need to specify what we attach it to. And it's our motion controller. Make sure you save everything. So I have a successful compilation of my project. Let's go to our hand and see the changes. As you can see, our hand mesh has been created, and it's a child of motion controller. Our all properties are here. We can set them. Everything is okay, and we can also see it in the viewport. The same way you do with blueprints. And also hand mesh is put in the same components category as we have right here. And also there is a way to make subcategories. And the way we make subcategories, we put a vertical line, make sure you do no spaces, that's important. Otherwise, this category will be called components, and this category will be called components space. So space is also a character in C++. Make sure you don't have it. And let's call it hint. Make sure you save your old CPP files. I have a successful compile, and let's see. Now we have components, and under components, we have another subcategory, hint. So that's pure decorative data. I always liked structuring my code, so everything was readable and understandable. Okay, so now we know how to create components. Now we'll need to create another component. In VRPwn, you can see we have a widget interaction component. We need this to interact with our widgets. So I hovered over it. It's called widget interaction component in the parentheses. That's usually the C++ name of this component. So your task will be to add our component, so widget interaction component, and attach it to hand mesh and make it through C++. So go ahead and do this right now. And you can also put your widget interaction component to the same category as you can see right here. You can pause this video, but I'm going to do it right now. Okay, so our widget interaction component, we should look for it. So widget interaction component, and we have a CPP file right here. Let's go to its header file. Let's look for it. So widget interaction component. Let's try to create it right away. I'll do something like this, and I'll call it widget interaction component. So to make your work faster and naming faster, what you can do, you can just copy its class name, paste it here, and remove U. That's how we can do it very fast. So we have red squigglies, meaning we need to include it. So let's go to our widget interaction component, to its CPP file, Control-K-O, and copy this line. Let's put it in our hand, like this, and make sure you put your includes before generated.h. Otherwise, you will not compile, and the compiler will tell you that you need this line to be the last one. Okay, great. Now we can put the same UPROPERTY, and let's go to our constructor, and make sure it's UPROPERTY. Let's go to our constructor. We are doing the same. We can copy this line, paste it in here. We need to specify the class. The class is UWidget interaction component. So widget interaction, I'll call it this way. And we need to attach it to our hand. So we're going to say widget interaction component, setup attachment, and mesh. So I'm going to compile and see my results. Before this, make sure you save your CPP. So my project has compiled successfully. Let's go to our hand. And as we can see, we have some error added and our widget interaction component attached to our hand. So this error component is being added automatically by C++. So don't pay attention to this error. And finally, we're going to add our last component to finish our setup. And let's go to VRPwn. So our VRPwn, to grab an object, uses sphere trace for objects, which is sometimes a little bit of expensive function. What I would suggest us doing is to create on the hand, to create a sphere collision right here. So when we press our grab button, basically we'll see what object is in this sphere and we'll grab this object. So I'll delete it for now. We'll create it in C++. But here is those 10% of cases where the thing written in the parentheses is not the same name as in C++. In our case, sphere collision is what is written here. But in C++, it's going to be called sphere component. So I'll delete sphere from here. I'll go to C++, and I'm going to search for sphere collision. I'll show you it doesn't exist. You'll not be able to find sphere collision CPP file in here. So the actual name is sphere component. And usually all the colliding components are called, for instance, box collision will be box component. Sphere collision, it's going to be sphere component, etc. So here we have our sphere component CPP. First, let's see if we need to write some include headers. So I'm going to copy this name in here to go to my VR hand. So if I write here, use sphere component, we'll call it grab sphere. We can see it's underlined, meaning we need our include header. So I will go ahead to my CPP file of sphere component. I'll look for this line right here, copy it inside of here, and I will give it the same property. I will go in my CPP file, I will have my grep sphere, I'll create a memory object for this sphere, make sure we include sphere component, and we'll call it grep sphere, like this. And we'll set up attachment. We want to make it a child of our hand mesh. So all we can do, we can copy this line, and instead of widget interaction component, we want to attach grep sphere. Okay, let's go and compile. I have a successful compile, let's see our hand, and as we can see, grep sphere was created. Now is the most important part. Make sure you don't miss it. It's very important. It's optimization. Okay, now, how we can optimize our code? Let's look at the include files. What include files tells us? Include files tell us about how functionality of those classes work, right? It includes its definition and functionality. Now, let's look at one of those blueprints. Maybe let's open a pistol blueprint. You can agree with me that everything written here is a functionality. So this is our CPP file. This is where all the functionality is written. So CPP file tells us about functionality. So this part is CPP file. What about header file? Header file tells us about what this object consists of. So in here, we have our header file on top left corner. So why does header file need to know about functionality? It doesn't. So let's bring those includes into CPP file. So what are the advantages of this? Imagine you had 50 includes in here, like that. So once you open your blueprint, those includes have to load, right? They have to load, and it may cause some lags, not only for your blueprint, but also for when your game starts. So maybe you have witnessed when you're opening blueprint, it's opening too long, and that is because all of those things are loading. And in C++, we have control over it. We can say when we want something to load. So that's why we use this optimization trick to bring the functionality to functionality CPP file. That's where we need this functionality, right? But in header file, we don't necessarily need it. That's a bit of optimization, but wait, let's try to compile it. After we compile, we'll see those errors here, and compile is failed. What it says: motion controller is not a member of hand. Widget interaction is not a member of hand. Grep sphere, not a member of hand. So now, what we can see, our header doesn't know what it is. And the solution for that is to use technique called forward declaration. What do? We write this line of code, plus your motion controller component. You remember how we define pointers, and by default, they don't point anywhere, right? The same thing happens here. We just create motion controller component. We tell our header file it exists, but we do not define it. We don't tell what's inside. So the same we can do with all other classes. So now we tell our header, again, look, I showed you what those classes are. Okay, a header file uses them, but header file doesn't care about what functionality is. That's why it's enough only to define it and tell, look, it exists. Well, you can use it. Okay, sure, header file uses it. But to construct an object, it uses C++. And in C++, we have those includes. So C++ provides all the information about this class. So just telling you again, .h file only needs to know about that this class exists, right? And CPP file needs to know what is the functionality of this class. That's why we include motion controller component here and define its class here. And this technique, again, is called forward declaration. This makes your code much more optimized and makes loading of objects inside your level much faster. You might not notice the difference, but when you have a lot of code in here, you will notice the difference. Okay, let's compile right now. Make sure you save your CPP file, and you will see that the compilation will be successful. And there you go, compilation is now successful. So nothing has actually changed. Our hand is as it was before. Okay, now, final thing. Why, if we go to our A actor, we use TObjectPtr with all the classes we have right here. You see, they never use pointers. You will not find pointers. They always use TObjectPtr. So, in Unreal Engine, there are a lot of types of pointers. Weak object pointer, smart object pointer, TObject pointer, all of those different classes. So basically, they're all pointers, but they have additional functionality on top to manage those pointers in memory better. That's all I will tell you right now, because I don't want to go into details. It might be very hard. TObjectPtr is same as pointer, but Unreal Engine manages it better. It's specifically created for Unreal Engine to manage your memory better, to make it more smooth. So we can go ahead and replace all of those variables in here by TObjectPtr and do something like this. And I'll replace it everywhere. remove spaces, make sure you remove spaces, you wrap it like this, and like this. There is no difference in code with those pointers, so you see same, there are no errors. We just treat them as pointers, but it's a custom pointer Unreal Engine provides us with. So the code is same as we were using pointers, but it's more optimized. So the management of those variables is more optimized. So let's compile, make sure everything works. As you can see, compilation is successful, and now we have a very optimized build hand class. And I will see you in the next part, where we'll make our first functionality.